not like specific like rectangular, circular we have seen. So as the rods are moved with a velocity v, what happened to area enclosed by the loop? So where is the loop here now? This will be the loop here. So let me give point A, B, C, and D. So the intersection of the rods here, this will make a loop. Present, what is the area of cross section? It is L square is given. Now after some time t, so this rod will be here. This rod will be here. So what do you expect? Area of cross section loop must increase. So we should take help of the diagram now. So after some time, okay, great question. Meanwhile, I'll adjust the diagram. After some time, so if you want, I can show it or why to mess up. This is what happening, no? Take like this here. Look at the area, it got increased. So earlier, the points AB was here. So no. Where was A? A was here. And B was somewhere here. Sorry, here A was here, B was here, C was here, and D is here. So now what happened? The A got shifted. Now A is here, B is here. Just do make observation, because some questions where they'll be very tricky, where if you draw a diagram little bit easier, it can be like this. So the initial positions, this were the positions of the rod. I'm putting with a dotted one. Now the rods are moved with a constant velocity. So here shall we say this length, let it be equal to x. Let this be x. What is the new area of the loop? So earlier it was L, no? Earlier it was L. So now shall we say it is, this was the L. Now what is the area of the loop will be now. So what is the side length? L plus 2x, and what is x? X should be equal to Vt, because the rods are moved with a constant velocity. X equal to Vt. So the new area at any time will be L plus 2x whole square. So this will be L plus 2Vt whole square. So what is the flux linking the loop? B into A. There's a uniform magnitude is there. So we got the flux. Now differentiate this. d phi by dt. 2B L plus 2Vt by 2V. So 4B V L plus 2 Vt. Okay, this is the expression for the EMF induced. Then what is the expression for current? I is equal to E by R. R is the total, lambda is the resistance per unit length. This one. So 4 BV L plus 2 VT will write. Lambda into perimeter 4 times, okay, the lambda into 4 times of, what is the perimeter of this will be L plus 2 VT is the side length and 4 times of that. So again, if you differentiate, again it will become BV by lambda. A constant current I in fact flows. Already previous class I discussed no the similar idea. So from where this L plus 2 VT has come? At t equal to 0, the rods were here. After some time t, it is here. At time t, what is the side length of the loop? L plus 2x. Write it. So I got this one. So now what is asking? Find the induced current in circuit at any time t. After that, power generated by exchange agent. Power generated by exchange. We should supply power for all 4 rods. No? So we'll calculate power generated on any one rod. Then this one. So what is the power issued? Write the equation. So what is the force you should apply? External force on any one rod. Let me calculate. No, anybody direction of induced current? B bar into the plane. Negative flux increase d phi by dt, negative. EMF induced positive. So the current should flow anti-clockwise. Then how BL force? BL force I should apply. BL force will be acting in this direction. FB. External force must be applied in this direction. So what is the F external is equal to? F external should be equal to BI L plus 2x. What is I? BV by lambda. L plus this is 2VT. Then what is the power? Power generated by exchange agent should be equal to 4 times of, because 4 rods it should pull up, no? 4 times of F external into V. F external is this particular thing. So you should apply a time varying force, and the power output continuously should vary with the time. And what all that power, where do it will go? Power dissipated in the circuit, because the velocity of the rods are constant. Then what happened to that power generated by exchange agent that we utilize to generate heat, or this entire the whole circuit will convert that mechanical power into electrical power. The rest, again the rods will convert that electrical power into the heat, the thermal power. Also this what you can write, power P external, also what you can write, power dissipated in the circuit. Power dissipated in circuit.
Sir, can you tell why power external is 4 into?
For the 4 rods I should pull, no, not only one rod. On 4 rods I should apply force, no. All 4 rods I should pull, no. So that's why the 4 times. Okay, fine.
Sir, how did you get direction of current, sir?
Negative flux, flux negative, negative flux increase the d phi by negative, EMF positive. EMF positive means induced current, positive means anti-clockwise.
Why is negative flux increasing, sir, here?
Area increasing, no. You see, look at equation with the time. T as with the T will increase, no.
Yes, sir.
So flux is increasing. Or
Okay.
stick on to the basics. Stick on to the basics. Nothing big.
Well, you need to take negative of d phi by dt, no sir, for finding E.
I am just getting only magnitude and the direction I'll predict by Lenz's law, because the mathematics again will here and there we may miss sign, we'll try to interpret some other way. That's why only magnitude I'll calculate, I'll indicate the direction in the circuit. That's what I'm following it here. Is it okay? So that the best way, because some numerical solvent where we'll calculate magnitude, then Lenz's law, the direction, then I'll continue into the problem. Or else the Lenz's law you should introduce here only. You should take care the Lenz's law here only. So that will be better. Make magnitude Faraday's law, let the direction be Lenz's law. You get that direction separated and let only concentrate magnitude. It'll be much easier for you. Okay, there's a force acting on each. Okay, so this is, so some different shaped structures will be coming for you. You have to be very careful. Different shaped structures will come. Yesterday we have seen triangle here, broad square. Any other shape structures will come. Power dissipated in circuit should be equal to how much it is? I square into, again, the resistance, total resistance of the circuit, lambda into 4 L